All right, and let's start with looking at number 1 from your review. Now, when we look at number 1, we're going to have to find the sine, cosine, and tangent of angle A. Now, to find the sine and cosine of angle A, I need to know the hypotenuse. And for this one, we don't know the hypotenuse yet, but it's a right triangle, so we can use Pythagorean Theorem to find out what that hypotenuse would be. And so to find that, it would be a squared plus b squared equals c squared, or, so it would be number 1, so or we can look at it as 4 squared plus 5 squared equals x squared. And 4 squared plus 5 squared, 16 plus 25 would be 41. So we'd have 41 equals x squared. And so I could take the square root of both sides, and I would get x equals 41. Now remember, technically, when we do the square root of both sides, we'd have a positive and a negative. But since we're dealing with the side of a triangle, we're not going to have a negative length. So all we care about is the positive value. So we know the hypotenuse now is 41. So now I can go through and we can figure out what the sine, cosine, and tangent of angle A is going to be. So the sine of angle A would be the opposite over the hypotenuse. Well, the opposite leg is 4. The hypotenuse is square root of 41. Now technically, we would multiply the top and bottom by square root of 41. And so now I would have 4 times the square root of 41 over 41. If you multiply, to get rid of the root from the denominator, you multiply the top and bottom by the square root of 41. And that gets, like I said, it gets rid of the root from the denominator, and in the numerator we'd have 4 times the square root of 41. Now 4 and 41 cannot reduce. If we could reduce that, we would, but that can't be reduced. So that would be the sine of angle A. Now the cosine of angle A would be the adjacent over the hypotenuse. So we'd have 5 over the square root of 41. Same situation, we'd multiply the top and bottom by the square root of 41 to get 5 square root of 41 over 41. Again, that can't reduce either. So we'll just leave it as 5 squared root of 41 over 41. And the tangent of angle A. Now the tangent of angle A is the opposite over the adjacent, so that would just be 4 over 5. That'd be your answer for that one. Now for number 2, we're left with the same problem. With number 2, we need to figure out what the leg opposite angle A would be. So we're trying to figure out that side for number 2. So that would be x squared plus 6.5 squared equals hypotenuse, which is 8 squared. Or I can take 8 squared minus 6.5 squared. Either way, I get 21.75. Again, if you're wondering how I got that, I just took 8 squared minus 6.5 squared. Now to get this, to figure out what x is, we would take the square root of both sides. And when you do that, you would get you get a decimal. We'll just round that to 4.7. So now I know that this side here would be 4.7. So now I have enough information to be able to find the sine of A, the cosine of A, and the tangent of angle A. So the sine of angle A would be so this is the side we're looking with, or angle we're working with. So the side opposite of that is a 4.7. So we'll just have that as 4.7 over over the hypotenuse, which is 8. You can leave it like that. That'd be fine. Technically, we could just do this as a decimal and divide 4.7 divided by 8. But for time's sake, I'll just leave it like that. And the cosine of angle A, we would take the adjacent leg over the hypotenuse. So it would be 6.5 over 8. The tangent of angle A would be opposite over adjacent, so 4.7 over 6.5. All right, let's look at number 15. For number 15, we want to find out what x is. Now, the first thing I recognize, this is a right triangle. So we don't have to worry about using law of sines or law of cosines for this. We could just use SOHCAHTOA. And the fact that I know the 67-degree angle, and this is opposite of that angle, and this is adjacent to that angle, tells me I'm going to use a tangent. So it'll be the tangent of the angle, which is 67 degrees, equals 27 divided by x. Now remember, the long way to solve this is I would multiply both sides by x, and then divide both sides by 27. But remember, you could get to that much faster just by taking, anytime we have an x in the denominator, just swap those two, and that would give you what we have here. X equals 27 divided by the tangent of 67. Now you want to make sure that you recognize when to use your calculator in degrees and when to use it in radians. So for this one, make sure your calculator is in degree mode. So when you take 27 divided by the tangent of 67, you get the right answer, which is 11.46. All right, let's look at number 16. So number 16, this is a situation that is a side, angle, side, because we know two sides and the angle between them. So this is a side angle, side scenario. So that tells me I have to use a law of cosine. So they don't tell us what to use. We have to know what to use. So again, make sure that you recognize when to use these different formulas. Okay, so with the law of cosines, remember we work with this angle. We're going to take the cosine of that angle. So on the other side of the equal sign is going to be the side on the other side of the angle. So I'm going to set this up to be x squared equals, and then we have the two sides, 45 squared and 117 squared. Then it's going to be minus 2 times the two sides, 45 and 117, times the cosine of the angle that makes up those two sides. When you do that on your calculator, we'll just round this to 6,094 point, just keeps going, 366. We'll just stop there. So to find out what x is, I would take the square root of both sides. Again, I only care about the positive value, and we get x is 78.1. So that'd be your answer for number 16. All right, number 17, we have to draw out our triangle here. Again, we're just using this triangle as a reference, so it doesn't worry of how precise or accurate you are. But I know angle A is 37 degrees. I know angle B is 72 degrees. Remember when we label sides, if you're ever wondering how to know what side is B, it's always going to be across from angle B. So side B is 8, so it's going to be across from the 72 degree angle. This is an angle, side situation because we know two angles and a side outside of those two angles. So we're going to use a lot of sines. So it'll be the sine of 72 degrees over the side across from it, which is 8, equals the sine of angle A, which is 37, over the side across from it, which is what we're trying to find. We're trying to find side A here. All right, so let's cross multiply. So when we cross multiply, it's important to make sure that you type it in your calculator correctly. So to avoid any mistakes, I like to write the number down times the sine of the angle. And then we'll divide by what's left over. We're dividing by sine of 72. And when you do that in your calculator, again, you can do that in 2 steps. 8 times the sine of 37, get an answer, and then divide by the sine of 72. But you get 5.06 as your answer for 17. All right, number 19. Again, we have to draw our triangle out here. Call this triangle ABC, or no, KLM rather. There we go. And angle K is 22.3 degrees. Side K is 32, so that's across from angle K. And side L is 53, so it's going to be across from angle L. And we want to find all the possible values for angle L. Now, there's a key word there. Find all possible values. Why would they say that? Well, let's look at what the situation is. This is an angle side-side situation, one of those naughty ones. This is an angle side-side situation. So there could be 2 possibilities. So we have to use a lot of sines. So it'll be the sine 22.3 over the side across from it, which is 32, is proportional to the sine of angle L, which I'm trying to find out what that is, over the side across from it, which is side L, which is 53. So again, we're going to cross multiply. So remember, write the number first. Makes it a lot easier, so you avoid making mistakes. So it'll be 53 times the sine of 22.3. Divide that by what's left over, 32. And when you do that on your calculator, when you take 53 times sine of 22.3 divided by 32, you end up getting 0.6285. And if I do the inverse sine of that value, we get our angle L is 38.9 degrees. Okay, so we know that angle L is for sure. One possible triangle would be where angle L would be 38.9 degrees. Now I've got to figure out, is there another possible triangle that we can make from this scenario? So what we do to figure out if there's another possible triangle here, we would take whatever answer we got, and again, this only applies when it's an angle side-side situation. Take the answer that we got and subtract it from 180. So in other words, we're finding its supplement. So when I do that, I get 141.1 degrees. Okay, now could angle L be 141 degrees, 141.1 degrees. Well, to find that out, well, we know one of the other angles is 22.3 degrees. And if I add those together, we get 163.4. So there's still some degrees left over for angle M, because if we have, if those two together make up less than 180 degrees, that means that there's some measurement left for angle M. If we add those two angles together and we get an answer that's more than 180 degrees, we're not going to get a triangle because you can't have a triangle that's more than 180 degrees. So our two answers for angle L would be 38.9 and 141.1. All right, let's look at 32. Now for 32, for the purpose of this year, I'm less concerned about coming up with a general solution as I am about finding both solutions here. So let's start with the first one. So the first one is already, the cosine is already by itself. So to find what x is, we would take the inverse cosine of both sides. But before we do that, make sure your calculator's in radian mode. If your calculator's in degree mode, you're going to get the wrong answer. So if you got the wrong answer for this one, remember you don't have to do 32 or 35, but if you got the wrong answer for this one, that's probably why. Because when we take the inverse cosine of both sides, you should get 0.82 as your answer. Now, we've got to find another solution here. So remember, the cosine function looks like this. Between 1 and negative 1, this would be pi and 2 pi. All right, so the cosine of x is 0.68. So 0.68 is, we'll just estimate that to be right about there. So that means that there are two values. All right, so there's two values where the point, where when we take the cosine of those values, we get 0.68. So one of those is at 0.82. So that means that this distance from here to here is 0.82 units. Well, that means that this distance here is also 0.82 units. So to find out what this value would be, we would take 2 pi minus 0.82. And when you do that, we get 5.46. So those are our two solutions between 0 and 2 pi, where the cosine of those would be 0.68. Now, if you wanted to come up with a general solution, remember this point, every point repeats itself. So this point would repeat itself right here, and it would repeat itself over there. So every 2 pi radians, it's going to repeat itself. And this one also, this point also is going to repeat itself every 2 pi radians. So it would repeat itself right here. And every 2 pi radians, that would repeat itself. So we would just add 2 pi and refer to all the other values. So that's what we call the general solution. But the most important part is how to find the 0.82 and the 5.46. All right, let's look at a tangent one of those. So for the tangent, this one's a little different. Now this one involves two steps here. So I'm going to add 9 to both sides and then divide by 6. When I do that, I get 1.5. So to find out what z is, I would take the inverse tangent of 1.5 and I would get 0.98. Now the thing about the tangent function is this, remember, it's different from the sine and cosine functions, but it repeats itself every pi radian. So between 0 and 2 pi, another solution here, because you're going to want to know how to do this on the test, another solution would be just to take 0.98 plus pi. And when we do that, we get 4.12. And so with the tangent function, the general solutions would just be 0.98 plus pi n. But on the test, I want to make sure you know how to find all the values between 0 and 2 pi. So the values between 0 and 2 pi would be 0.98 and 4.12. So make sure you know how to do that. All right, let's look at number 38. So 38, it says in triangle URN at the right, identify the cotangent of U and the cosecant of R. All right, so the cotangent, remember, is reciprocal of the tangent function. And so the tangent would be, so the tangent of U would be U over R. So the reciprocal of that would be R over U. So that'd be your value, or that'd be your answer for part A. For part B, remember the cosecant is the reciprocal of the sine function. And here we're looking at angle R. So the sine would be opposite over hypotenuse, R over N. But in this case, it's the cosecant, so it's the reciprocal of that. So it's going to be N over R. Would be your answer for part B. And number 39, if the cotangent is 3 over square root of 10, what is the value of the sine of theta? All right, remember the cotangent is, it's going to be the cosine over the sine of theta. So if that's the case, that means the sine of theta is going to equal the square root of 10. So our answer would be that the sine of theta in this scenario would be square root of 2. I'm sorry, square root of 10. There we go, square root of 10. All right, let's look at number 40. 40 asks for the exact value of the secant of pi over 3. Now, pi is the same as 180, and 180 divided by 3 would be 60. So this is the same as 60 degrees. And so the cosine of 60 degrees, if we just start there, because the secant, remember, is a reciprocal of the cosine function. So first I'm going to identify what the cosine of 60 would be. Well, that would be 1/2. So the secant of 60 degrees is reciprocal of that. The reciprocal of 1/2 is 2 over 1, or just 2. For 41, it says give the exact value of the cotangent of negative 765. So I like to look at it this way. Well, that's 765 is 2 full rotations is 720. So if we took 720 plus 45 degrees, that would be the same as 765 degrees. So we're looking at, this is the same as cotangent of negative 45 degrees, because we'd go 2 times around, going in the clockwise direction plus another 45 degrees. And that's going to bring us down in quadrant 4. In quadrant 4, remember, it's going to be cosine over sine. So the cosine in quadrant 4 is positive, so we're going to have the cosine of that would be square root of 2 over 2. And the sine is negative, so it would be negative square root of 2 over 2. So remember, since we're dividing them top and bottom of the same thing, our answer, they would cancel each other out, leaving us with 1, or in this case, negative 1. All right, let's look at number 46. In 46, it says in triangle EFG, angle E is 30, EF is 5, and FG is 8. Alex claims there's exactly 1 triangle. And Keisha claims that there are 2. Who is correct and why? Well, let's draw our triangle, because that might help. So this is triangle EFG. Again, your triangle doesn't have to be perfect. We're just using this as a reference. So if you label the sides, this is what we would get. So if you notice, this is a ASS. It's one of those bad ones, one of those naughty ones. And so remember, there could be 2 possible ones, but just because it's an angle side side does not always mean that there will be. So let's find out if there's going to be 2 triangles. So we would use a law of sines. We sine of 30 over 8. And since I know the side that's 5, I'm going to do the sine of G over 5. So we'll work on this and figure out what G is. So when I cross multiply, I would say sine of G equals 5 times the sine of 30 divided by what's left over, which is 8. And when you do that on your calculator, we get 0.3125. So if I take the inverse sine of 0.3125, I get about 18.2 degrees. So we know that there's at least 1 triangle there with an angle of G at G of 18.2 degrees. Now, remember, there could be 2 possible scenarios here, because we could flip this 8 and have it be a bigger angle. Let me take the time to do that right now, but remember that there could be 2 possible triangles here. So to find the other 2 or to find out if there is another triangle, we're going to take the supplement of 18.2 degrees. So I'm going to take 180 minus 18.2, and when I do that, I get 161.8. So could the other angle be 161.8 degrees? Well, let's see. If I add the other angle that we do have, 30 degrees, we get 191.8 degrees. Well, all triangles have to be less than 180 degrees between all 3. And here we have over 180 degrees with just 2. So we know that there's not another possible triangle, so there's only 1. So that means Alex is the correct one here. Let's look at number 56. A ladder against a wall makes a 75-degree angle. Okay, so let's draw our ladder with against the wall here. So this angle here would be 75 degrees because it's 75 degrees with the ground. The base of the ladder is 4 feet from the wall, so the base would be down here. It's 4 feet from the wall, so that would be our bottom down there. We're trying to find the ladder's length, so we're trying to find the hypotenuse of this triangle. This would be our right triangle, so we can use SOHCAHTOA. So since we're using the adjacent leg, I'm going to use the cosine of 75 degrees equals that adjacent leg over x. over the hypotenuse. Now remember, we did this earlier if you were watching from the beginning, but if you didn't, I'll show you again. So to get rid of this fraction, we would multiply both sides by x, and then we would have x times the cosine of 75 equals 4. And then to figure out what x is, we would divide both sides by the cosine of 75. But remember, we can get there a lot faster just by taking the x, cosine of 75, and switching them. That would give you x equals 4 divided by cosine of 75. So it's a little trick, so you don't have to do it this long way. But when you type that in your calculator, 4 divided by the cosine of 75, again, making sure your calculator's in degree mode, because if it's in radian mode from one of the previous ones, you're going to get the wrong answer. But we get 15.5 feet. All right, let's look at this one. It says a building casts a shadow 22 meters long when the elevation of the sun is at a 51-degree angle as shown in the right. How high is the building? So we're trying to figure out how tall that building is, and again, this could be a right triangle. So in this scenario, this would be the opposite side, and this would be the adjacent side. So we're going to use the tangent function. So tangent of 51 equals the opposite, which you don't know, divided by the adjacent leg, which is 22. So to find out what x is, we multiply both sides by 22. So we're going to take 22 times the tangent of 51. Again, make sure that your calculator's in degree mode or you get the answer wrong. And when you do that, you get 27.2, and this would be meters. Is your answer for number 57. All right, number 60. So for this one, we're trying to find the distance across the lake here. We're trying to find the distance for AB. And so if you look at this situation, this is a side angle side situation, because we know two sides and the angle between them. So this is a side angle side. So we use a lot of cosines. Come back. All right. So we're going to use a lot of cosines. So it would be x squared equals the two sides squared. So 94 squared plus 184 squared minus 2 times those two sides. So 2 times 94 times 184 times the cosine of the angle, and the angle is 42 degrees. Again, for this problem, make sure your calculator's in degree mode. If you're getting the answers wrong, that very well could be y. So make sure that you don't make that mistake on the test. And so when you do that, you get 16,985.13, we'll say. So we can round it to. And so if I take the square root of both sides, we get 130.3, and this would be meters. It's the distance across the lake. All right, last problem. Let's look at this one. So this one, we're going to have to draw out a diagram. So we have an airport controller notes that a plane 14 degrees west of south and 20 miles from the airport is flying toward another plane that is 18 miles directly south of the airport. The planes are at the same altitude. How far are the planes to the nearest tenth of a mile? Okay, so we're going to put the control tower at the origin. And 14 degrees west of south. Well, this is south. And so 14 degrees west of south, we'll say this is 14 degrees. It's a little bit more, but so we have more space to work with. So let's say this angle here is 14 degrees. Okay, and that's one of our airplanes. And it's 20 miles from the airport, so this will be 20. And we have a second flight that's directly south of the airport, 18 miles, and we want to figure out how far apart these two planes are. So we're trying to find that distance. So if you notice, this is a side angle side situation, so we're going to use a lot of cosines again. So it'll be x squared, because that's the side across from the angle, so it'd be x squared equals those two sides, 18 squared plus 20 squared, minus 2 times each of those sides, 18 times 20 times the cosine of the angle that makes up those two sides, 14 degrees. And again, make sure your calculator's in degree mode or you're going to get the wrong answer. And if you do this, it'll be 25.387. We can round that to. So if I take the square root of both sides, we get x equals 5.04 miles. So that's how apart the two planes are. If you're wondering what this information is about being at the same altitude, that just means that you can say that they're on the same plane, so to speak. So it would be a flat triangle is what we're working with. All right, so hopefully that answers the questions that you had from the review. And if you still have some questions on those, just like normal, please make sure that you talk to me so we can get those figured out before you take the test.